Yeah, you got the Hi, John. Good morning. Can you hear me?
Yes, sir.
Okay, perfect. Yeah, let's just wait for them. So how was the lab yesterday?
We had additional practices about the lists. I also introduced the tuples.
Oh, okay. So we can just run through that part today and immediately transition to dictionaries. I think we can finish dictionaries pretty quickly, and then um, yeah, let me think. Tomorrow would be conditional statements if we can do that. Okay. So I'll be idle for a while. I'll just turn off my camera while waiting for the students.
Okay, sir.
Hi, Asibo. Welcome to the
Hello.
meeting.
Thank you. Can you
How
hear
are
me?
you? Yeah,
I'm
I can
good.
hear you
Good.
clearly.
Yeah, thank
Thanks for
you.
being on time. Um,
No
yeah, let's
problem.
wait for a couple of minutes for the others to join, and then we should
Sure.
start. Okay,
Sure.
thank you. Hi, Grace. Welcome to the meeting. How are you? Okay. Yep. I hope you're hearing me clearly. So I think we should start. I don't want to keep you waiting for long. Um, so let's have a quick recapitulation of the discussion last time, and then we should immediately proceed to the topic that we have for today. So we started the discussion the last time with data structures. I said that you can think of them as like containers. So instead of just working on a single string or numbers, it's completely possible for us to create this collection of numbers or combinations of them. And let me see. Do you see my screen now? Not yet. Okay. How about now? Can you see it? Okay, cheers. So, yep, as I was saying earlier, we talked about the data structures. Um, so we have extended the idea, okay, the slicing and the indexing and all of those stuffs for this collection of objects. So the collection, for example, when you have a list, it could be a collection of numbers, strings, or characters, or even booleans, right? So we can group them all together. And the one thing to remember with lists is that they are ordered, so we can slice it through the slicing process that we learned for strings. So using the index tables, we're able to somehow create a subset or um, get a smaller version of that collection. So we are through with that, and I think John uh, introduced to you the concept of tuples. So the main difference between the two is that the tuple is immutable. Let's see. Hi, Jeff. Welcome to the meeting. Hasiba, can you tell us something about
Hey, how's it going?
the difference between um, immutable and mutable collections? Like, what do we mean when we say that um, a list is a mutable set or a mutable collection?
Mutable, you can change
Exactly.
the value and the string to integer or integer to the string, but immutable you cannot change.
Yeah, yeah. Perfect. So from the root word mutate, right? Changing. So that's how you easily remember that. So when we say a collection in Python, so this also applies to other programming languages as well. When you see that word mutable or immutable, then it's just referring to changing. So here, changing the elements or the object inside the collection. So we have also learned this different methods, right, that we can apply with strings. So may I ask you, Grace? Grace, are you at work today?
Negative, sir.
Okay, okay. Um, yeah. So can you give me a method or a function, anyhow you call it, it's just the same, that would allow us to drop the last element of a list?
Like pop?
Perfect. So that dot pop would allow us to drop the last element of our list. How about if you want to remove a specific element in our list?
Me?
What what method can we use?
Um, the remove function
Exactly.
and
So
for list?
it's easy. Yeah, it's easy to remember the functions in Python because The function name is what it does, right? So the remove, you can specify in its argument inside that parentheses the actual element that you want to remove from your collection or specifically from your list. So there are so many of these. There's so many of these methods. Um, so I just introduced to you this typical ones, but in reality there are even more. So well, it depends on your goal. So if you're looking to manipulate your list, there are tons of guides in the internet that would give you the different methods, the different functions that you can use. Okay, but now what I want you to remember is that when we work with list, here are these possibilities. Uh, here are this um, example methods that can be used, and of course um, with other collection types, you cannot do that. Like for example, with tuples, you cannot just apply the same methods that you have with list on that. So, yep. Any clarifications or anything that confuses you on this part? John, can you ping Anissa, please? Thank you. No questions. So I assume that everything in this part is clear. Okay. So hearing none, I think we can move on. So I'll just run through this topic, tuples, because you've already discussed it with John. So I want to highlight some things here that a tuple, unlike list, this is immutable. Okay, you cannot add or delete elements from them the same way that we did with list. However, um, well, also it's still ordered. So whenever a collection is ordered, we can make use of the indices to somehow access the elements of that collection, right? So here, can you remember what operator do we use for list? You see, for tuples, it's parentheses. How about for list? Jeff, can you remember? Like when you're creating a
Yeah,
list without the
it's
list
a
function,
square bracket, the square
the
bracket.
square brackets, perfect. So take note of that. So these different collections, they use this different operators. So knowing which one is for which is good. So here we are creating a tuple. We have again different data types here. We have strings, okay, um, cars or trucks. This is a brand. This is I think a type of vehicle. Raptor is like a truck, and then the color. Then the year model is 2019. So similar with list, we can in a tuple we can combine different data types, and we can apply uh, the len function, the indexing and slicing, all because it is ordered. That's the reason. Okay, remember that if something is ordered, then you can apply the same principle as with lists. You can look into the number of elements inside it through the len function. That's what you're seeing right here in the first part, and then you can access certain part of it. In this case, we are accessing this um, second element, which has this index value of 1, which corresponds to like the model, and then slicing. So the typical slicing that we did with lists. So I think you've finished this practice creating your tuple. So again, the secret here, it's not really a secret, but it's a thing to remember is that we're using parentheses. Okay, we're using parentheses. So the idea is still the same as with list, but the difference is you're using parentheses instead of square brackets. So it's perfectly fine. It's working if you try to merge the tuples, similar as how we did it with list. So you can use the plus operator to merge the elements of the tuples. And it's also possible to nest the tuples. So you will be accessing this nested tuple in the same way that you accessed um, the nested list. So you will be using the double square bracket for that. And that's it for tuples. So now, do you have any questions with tuples before I proceed to dictionaries? So you might be thinking, oh, why do we have these different containers? Well, it's again, well, sometimes it depends on your preference. If you're more comfortable working with a specific collection type, sometimes it's a matter of efficiency. Like you would be easily working or creating a collection on a specific collection type, such as dictionary. Because also in terms of efficiency, um, the the dictionaries are consuming less memory as compared to other data types. But they're comparable. They're comparable. But for me, I would be preferring always a list because of its mutability property. So I would want to have that. Well, there will be instances that you don't want that property. So if you want to like add additional security, right, um, to your collection, you don't want it to be mutable. You don't want it to be easily changed. Okay. So there are these methods. Different methods work on different data types. Okay. And just like that, we'll be switching um, to this topic for today, which is dictionary, the last type of structure. Or maybe I think tomorrow I'll be introducing to you sets. Um, I think I've prepared some time ago some a lecture about sets. Let me just find it. So do you see again my screen, guys? Okay, perfect. So yeah. So the last one here that we have is dictionaries, and then after that, we will be talking about how can we convert one data structure to the other. So similar to how we converted data type, right? We converted string to a number and the other way around. It's also possible to do that for data structures. Um, well, for you will be doing this for following reasons. You want to convert an immutable type to a mutable type, or the other way around. Okay, so that's the primary reason for converting data structures. So also, it could be that there's a specific method that would accomplish your goal. If you're, say, manipulating your data, you can convert it to that data type so that you can apply those methods. Okay, so yep. So let's talk about dictionaries. So the dictionary is completely different to what we've seen with tuples and lists, and even with sets. So this is like the unique data structure. And for me, again, I've always said that this is the most efficient way because it's requiring you less memory to store your information, to store your data. So the difference between a dictionary and the other is it has this set of key value pairs. So you can imagine it as like a student ID and then all the other information associated with that student ID. So the student ID would be acting as the key, and the values would be the values. So the values could be on the form of, say, the grades, or height, or weight, or any other thing. Okay, so Each unique key is an index which holds the value associated with it. Of course, with keys, we want it to be unique. It's not it's not logical to have non-unique keys because it doesn't make sense, right? So we assign keys so that we can uh, easily discriminate one record from the other. So one thing, okay, as compared to lists and tuples, dictionaries are unordered. So you cannot use the typical slicing that we have done uh, to dictionaries. So you can use the square brackets. Okay, so we'll be moving away from that. So in Python, we must put the dictionary's content inside curly brackets. So remember, list, square brackets, tuples, parentheses, and then we have curly brackets. Okay, so those are like the easiest way to determine what data structure you are working with. Once you see those operators, right, you can easily distinguish it. So a key value pair is written in the following format. So you have the key followed by a colon and then the value associated to that key. So I have here a visualization of how a dictionary would look like. So you have a key and then the value, key and then the value for the other, the key and the value for the other occurred. So let's see. Creating a dictionary. So there are multiple ways of creating a dictionary. Um, okay, sorry for that. So um, there's a function. There's a function to create a dictionary, and similar to the list and tuples, you can also use the operator, the curly brackets, to do so. So it's also completely possible to create an empty dictionary that you would later fill in. So here I have this example of a phone book. I have here Batman, Spider-Man, and Wonder Woman. So these are the keys. So the names are the keys here. So you have Batman in there, and then the associated value is like 555. Well, like I just made it up. That refers to the number, phone number, and then we have Spider-Man and so on. So as you can see, you have the key and then the value. You have the key and the value. So that's um uh, the structure of a dictionary. As you can see in here, you have this output once you print the phone book dictionary. And it's completely possible. So as you can see at the bottom, we can create an empty dictionary. Okay, and then later we can fill up this empty dictionary with key value pairs. Okay, so there's this. Once we talk about conditional statements, typically you would be starting with an empty collection, and once the conditions are being satisfied, it would be automatically propagated with values. So that's one of the reason why you would be having an empty collection such as this, an empty dictionary. So that yeah, you can start with a clean collection, and then every now and then that it satisfies the conditions. Again, depending on what condition is that, it will be automatically um, filled in. Okay, and then yep. Any questions, guys? Any questions regarding this? Okay. So a note about dictionaries being unordered. Okay. Since a dictionary is unordered, the order of the output will not necessarily match the order in which we wrote the entries. So that's one thing. Okay. It's not an assurance that how you wrote it would be exactly how it would be shown in the output. Key value pairs are accessed in a random or unordered manner. So it's not the case that, okay, the first one in the list or in the dictionary would be this because you made it that way. So it's not like that. Okay. So it doesn't have that property as compared to tuples in the list. So you might think of it as like one disadvantage of uh, putting your data into a dictionary, but it's also one way for it to reduce that memory or larger memory requirement. So this is another way to create a dictionary. So using this dict function, um, yeah, basically it's almost the same. However, notice that this is a function. So you have the parameter, or how should I say this? The argument inside. So if you would ask me which I prefer, this or the first one, I'm more comfortable using this, right? Because in here I'm not using any function, although the function can easily be remembered. But I have this distinguishing operator, right? The curly brackets. So for me, this is an easier way to create a dictionary, and it follows that structure of a key value. But I just added it here so that you're 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 knowledgeable that it's completely possible to create it this way. Okay.
So can we look at a dictionary as like a list of variables?
Um, list of variables. Yeah, I think you can say that. Um, but with dictionaries, there is this association between your key and value. So your key could be uh something constant, and your value would be something that should or could be considered as a variable. But both, well,
Oh no,
basically
I'm
both.
saying more like the key. Isn't the key like a variable in that? So like, do you usually sometimes would you just call Batman and automatically get like the 55555 value?
Yeah, yeah,
Is that how it
exactly.
works?
Yeah, yeah. So if you look for Batman, then the 555 would also be um shown up, and other associated values to it. Yeah, but you can actually change that, and um so makes me think that both of the keys and the values are considered as variables. But yeah, one thing is that whether you treat it as a variable or not, the keys must be unique. So it's not possible that Batman would appear in your dictionary twice, but with a different value. Do you follow, Jeff and the group? It could be that Spider-Man and Batman have the same numbers. They're, for example, living in the same house. So just an assumption. Um, then they would be having the same value, 5555 or 2222. But the key should be different.
So there will be only one Batman and one Spider-Man, but Batman can have multiple values too, right?
Yes,
Is that
exactly. Yes, yes, that's
okay?
completely possible. Yeah. So, in fact, this is the thing that I'll be discussing next. So, the keys and values can have any of the basic data types or structures. It could be in the form of a list. It could be in the form of a tuple. But one thing to remember is that the keys are unique. It's not. It doesn't make sense to like have the same keys in there, and it would not allow you. If you try, it would throw you an error. Okay. You don't want to confuse yourself and even the system that you have the same keys in there. Keys,
And then the same
whatever you call.
value essentially, it's just the same numerical value, but it's
Yes.
in reality like whatever the
Uh,
address, the code address, there will be all different and stuff like that. It's just
in
their own
fact,
identity.
yeah. In fact, with the values, it doesn't necessarily need to be a number. Um, it is completely possible to create a dictionary in which the value assigned to it is a string. That's what we have in the first bullet. That both the keys and the values could be on it on like a different data type or any other data type or structure. In fact, your key could be a number. It's perfectly like it's a typical thing that keys are numbers. But you won't treat it as actual number again. This would throw us back to the like level of measurements of things. So not necessarily that you see a number is already considered a number. It could be that it is nominal in nature, while it is a number. Okay, on the surface, it acts as an a character or a string, right? So yeah, it's just a way of distinguishing things, right? And it's easier to have unique keys if you have them in numbers. Maybe we can try that. Let's switch to our collab. Let me show to you that it's completely possible to do those things. By the way, guys, I have something to share to you. Uh, we were able to publish again another paper after 2 years. Imagine that. It was going back and forth for almost 2 years. It was published in an international journal. I'll be sharing to the group the link later so that you can see it. We'll be discussing some of the methods that I have used there. Um, regression analysis that was done together with researchers from UK and mostly Saudi Arabia. So let's have exploration. Sorry, I'm so used to SQL that even the comments, I'm still using the dash. Exploring dictionaries. So say I have this my data in which this is a dictionary. So I have this key value pairs. So maybe we can assign it as like a one and Jeff, and then two and John, and then three and Grace, and then four um, Hasiba. So we have that in here. So we switch the thing. So instead of having this name, we are, so let's see the type of this, my data. So it's a dictionary, right? And then what we can do is when we print that, why am I, where's that coming from? It's always date. Okay. So when we print it, you would see that, okay, again, these are numbers, but you don't treat them as numbers. You treat them, well, as names or as a way to distinguish one key from the other. So they are nominal in nature. And you have here the values which are um how do you call this? Strings or characters. I can even I think I can even create a list out of this. Say Jeff and Jeff. Jeff and Jeff too. Okay. So I think this would allow me to do that. So as you can see, now you have two Jeffs in there in the first key. So if you try to do, say, I have a non-unique key, let me see what would happen. Uh, did I run this? Yeah, I run this. And I'm surprised that it run. So, however, as you can see, um, the first one is not even showing, right? We lost that information. And if we try to put another one in here, we would lost the information about John. So it disregards. So once it encounters this, it disregards that. Once it encounters another key, so it would think that this is just like a misencoding or an error, something like that. So always remember that this should be a unique thing, so that the system would recognize that um, those are different inputs or different elements. Okay. And I'm surprised. I was expecting an error here, but seems like with IDs. Let me think. Run Python online. That should throw us an error. I can remember it correctly. Let's have a different IDE in here. Um, my data equals 1 and Jeff. I can just copy that. Why am I even typing? Just to see if this would work in here. Um, yeah, it did not give me anything. Let's print my data. Yeah, it does the same thing. It skips those parts with like the first item having the same keys would be regarded as like a misencoding, and it would skip that. This is also an IDE, so maybe I was thinking about the like the native Python. Okay, so any questions with this? And again, it doesn't make any sense if you try to like create uh, a collection or a dictionary for the purpose of storing your data and you assign the same keys to that. So in the future, that would give you tons of problem. Okay, always remember that. So going back here, um, so we have here true or false. We can access the elements of a dictionary using indexing. Pasiba. Is it a true or false and why?
Can you please repeat the question?
Yeah, we can access the elements of a dictionary using indexing.
Um, True.
Why?
I'm not sure.
Yeah,
Dictionaries.
it would be fine. I mean, if you
Yeah.
commit mistakes or
So
not.
if we think as like less than tuples, yeah,
Hmm.
so we can do indexing
Okay,
here as well.
so let me ask you this: why is it possible for us to access the elements of tuples and lists? What enables us to do that? What property or characteristic do this two collections have that allows us to do that?
I, I don't
You can
know.
call a friend. You can call a friend. Okay. You can call either Grace or Jeff. If
Yeah, maybe Grace.
okay, Grace.
Yeah.
Hasiba is
Uh,
using a lifeline.
okay, if I get
Call a
this
friend.
right, then you have to add me to the dictionary of superheroes because I saved the day. But
Sure. Hmm.
I'm gonna answer false because it's the what did we say? Unordered in
Hmm.
dictionary, and so in lists
Perfect.
and tuples, tup,
Hmm.
I don't know the word.
Tuples. Yeah.
We have indexing to be able to or index labels in order to recall them,
Hmm.
but don't
Perfect.
have that here, right?
Yes. Perfect. Perfect. So yeah. So again, the reason for us being able to access the elements via indexing is because the first two collections are ordered. Remember, we have those 0, 1, 2, 3, 4, 5, and so on assigned to the elements or to the objects of those collections, both with list and tuples. We don't have that in dictionary. So the answer is false. Okay, we cannot if you try it, like let's go back here, and maybe you are wondering what would happen if we try to slice it. Um, let's see. Let's slice it this way. Oh, it's giving me. Wait. Type dictionary still. Let me fix it. Okay. Okay. Let me try with 5, 4. Uh-huh. Okay, so what's happening here is I'm using the keys, but I'm not necessarily slicing it the same way as with the ordered pair. Okay, so this should not be confused with the slicing that we did with the previous. So for example, I have here a tuple, say ABC to make it simple. Let's clarify this. So when we create this object, this structure, print tuple, what we're essentially doing here when we create this is, well, the system automatically assigns, since you created a tuple using this parentheses, it assigns that A has an index value of 0, right? So if you try tuple 0, it would give you the A. However, it's not the case in here. So um, the thing happening here is what the square bracket is doing. It gives us the record associated with the key. So from this my data that we have at the top, let me just copy it here. So from this my data, okay, what's actually happening in here is this thing, when you use it, it would give you, oh no, should be my data, not tuple. It would give you the value associated to it. So if we change this into something like uh, handsome, okay, Jeff and Jeff too. If we try to do that, you see that it can identify a 1, a key of 1 in our dictionary. But if we try to put handsome in here, right, it would actually identify that Jeff and Jeff too are handsome. Just an example. Do you follow? So yeah, this is accessing elements in a dictionary, which is supposedly next few slides. So going back to this question, why is it not allowing us to do the typical slicing that we do with tuple and list? The reason for that is it's unordered. Okay, it's not an assurance that how we created it is how it would be um, in the result. So let me see. My data, but I think it would show it like this way. It's just a short list or a short dictionary, but it's not always an assurance that it would show something like that. Okay, that's why you cannot use the typical slicing. Okay, was it clear, everyone? Any questions? In fact, I'm even thinking that. Mm, let me see other things in here that I need to stress out. Mm, yeah, I think that's all for dictionary. So yeah, let's proceed to other questions I have here. Several values can be the same in a dictionary. Jeff, is it a true or a false, and why?
Yeah.
Why?
Uh, several values. I mean, the values can be the same. The keys cannot be the same.
Yes. In fact, for example, if you have a dictionary of students and their corresponding grades, more than one student could potentially have the same grade, right?
Yeah, no, I'm
But
also thinking in the super, like in the Batman or whatever, we could
mhm,
assign heroes as their value, superheroes as their value, right? Like, so they're all superheroes. So.
yeah. So we can associate John, right? So we can have two Johns in there for the values, right? And it's perfectly fine. That would still work. So we know that this first John is a different from the other John, right? So there are like how many John Smiths in the U.S.? It's like a common name. So that's the reason for that. But this keys should be the ones that are unique, so that you can distinguish which John is which, right? Whose John is you're looking for. So that's the reason for that. So yep, that's correct. Values are allowed to be the same as other values in dictionary. And lastly, several keys can be the same in a dictionary. Already answered this. Keys must each be unique in dictionaries. The keys are how we uniquely identify the values. Right. So imagine a very um, chaotic process of storing your information in which the keys are common, right? You have common keys, so that doesn't make any sense. It will just bring so much confusion and potentially error. So practice creating dictionaries. I'll be calling someone to share the work. Um, Jeff, are you in front of your computer? Can you open your collab and try creating a dictionary for me?
Sure.
Okay, so I
Uh,
have here the steps.
or would you be able to just? Can I just tell you how to do it, or
Yeah, you definitely let me open my collab, and John, can you paste
yeah?
a
I'm
screenshot
having a
of the
little
thing
issue with
here?
the my screen sharing, so
Yeah, no problem. So just guide me
okay,
in how I can answer this. So we have the screenshot on the
okay.
chat box, and then
Yeah, let me see.
let's do it.
Uh, so would it be? Let me see. First name.
Okay.
Uh,
So first underscore name equals.
uh, wait.
Okay, how should we
Is it?
start
Is
this?
it? I thought it's. I thought it's. Uh, maybe dictionary equals
Okay, so what is the name of the dictionary?
name or prof name.
Should I call it a name?
Sure. Name and a DICT.
Okay, me and then DICT.
So
So you're
DICT
using a function, right?
and the first name first. So first underscore name.
Um, first underscore name
Uh, column.
colon.
Uh, column. It will be a Jeff inside the quotes,
Okay, Jeff,
and then
and then
it'll be like a comma.
okay,
It'll be last name. So the last
uh,
underscore name,
first underscore name colon, right?
and yeah, column, and then YAN inside the
Yan. Okay.
yeah, and then
Mhm.
let's see, and then so the last one will be city equals
PT
no
equals
not equal, yeah, colon.
colon
Uh,
Seattle,
let's just put LA.
LA. Okay.
Yeah.
Hmm. Well, let's see. Collab is telling us something, so let's see. Invalid
Oh
syntax.
no,
So there's something wrong. Can you help me find it?
let's see. Wait, is it? Oh, it doesn't matter if it's single or
Yeah, it's telling you the problem. The semicolon is the colon is actually the problem, right? So what
yeah.
could be the fix for this?
Uh, is it? It's. I don't think it's equal sign, right? It's not.
Why not? Why not we try it?
Okay, fine.
Should we try
Equal.
equal sign? Okay, and let's see if it would work because it's telling us that something is wrong with the colon. Oh, it worked, right?
Wait, but earlier you were using column. How come right now it's using equal sign?
Yeah. So let me just close this one. So what do you think is happening right here?
Is this a
Mm,
tuple?
no, it's a dictionary. It's a perfectly working dictionary, guys. Print
Then if
type.
it's a dictionary, why we don't use the curly brackets?
Is it
Yeah, it's
because
a dictionary.
is it because we're assigning a string? We're not assigning a int. Like earlier, it was an
No,
int.
no. So, hmm, what could be the difference of this and the other one?
Because we're using a variable. Earlier, we're using a
No,
key. No.
not really. So,
Hmm.
let me provide the answer here. So, for this, we're actually using a function. The DICT is a function, right?
Okay.
And earlier, I did not use any function because I used the curly brackets. So there are like for this
Oh.
one,
Okay.
if you say if I create a list, I can use the list function and I can have one,
Got
two,
it.
three. It would still be a list, right? Oh, yeah.
Got it. Okay.
However, I explicitly created it through the list function. So, uh, wait, list expected at most one argument. Uh, wait, I'm forgetting something with the list function. Uh, yeah, anyway, but yeah, going back here, let me remember this thing why I'm encountering this error. So going back here, staying with the topic is here I did not use any function and just use the curly bracket, similar thing as with the square brackets and the parentheses. With this, we actually use the function here.
Okay.
I think I'm missing a thing
And, and
with
by
the
using a function, we're actually using we're using the method of variable assigning. So earlier we
exactly.
actually so if we use the earlier method, we will actually put a quotation mark around the first name also.
Um,
No?
yes,
Okay.
yes. So this would be a key, right? So since this is now you're correct in saying that you are using a variable right here, but let me think if
So if we
mm,
do the other method, then we would take out the dict, but then put a curly bracket and then put a
yeah,
quotation mark around the
quotation
first
mark.
name.
Yeah,
Around the
the
first
reason for
name.
doing that is we're not applying it inside the function. So if we do that, the system would think that you are referring to something,
Okay.
some other values. Like for example here, you might be thinking, like for example, if you have a handsome here, handsome could be any other thing, right? It could be say
Mhm.
a handsome that's already in the system, so it could be equal to 1. So in that way, as you can see, the yellow thing here was removed. The system would look for the handsome word, since it's thinking that it is a variable. So once you run it, it knows that, okay, it's just a value equal to 1 here.
Okay.
Let me
And
think.
then
It's not picking. Ah, no. Because we have it here. So if we print
okay.
it, yeah,
Mm,
if we print it here, you would see that it is now equal to 1. It's missing here.
mm,
Yeah. Now
okay.
I just remember the issue here. Um, I forgot that the list actually takes into consideration a thing that you want to convert into a list. So it's not something that you would use in order to create a new list, but you use that function to convert one data structure into a list. Okay. But by the way, we'll be talking about this, so don't worry about this thing. I um I just remembered it now. Um, oh, sorry.
So you would choose one method over the other. Is it because the earlier method, you could assign multiple values, and the way that I did it, I couldn't assign multiple values.
You can actually still do that here. I mean, you can create a list. It gets any particular data structure. So basically, they're comparable. So it's only depending on your preference
So
if you want.
why would you why oh so it's just a preference. They do the exact same thing.
Yes, they do the exactly same thing. However, this is through a function, and the other one is through the operator. So it's like the same thing as with concatenate function in SQL. That both ways are doing the same thing, but it depends on your preference and how you would combine it together with other codes that would make you choose which method you would use. Does it make sense? Was that
Yeah.
even clear, guys? Okay. Yeah. So how about the others? Grace, Hasiba, do you see the issue earlier here, or was everything clear? So, yep, hearing none, I think I can assume that everything's clear. So, um, basically, that's how you do this. How you would create your dictionary and the thing. So, it depends on you. It depends on you how you would create it. And um, personally, I prefer this one. I prefer this format. I always create my dictionary this way. For me, it's just natural. It's just natural for me to do this way. So, yep. Let's proceed. How about accessing values? So we actually did this earlier, but there are two methods for this. One is through a function, and one is through the keys and using the square brackets. But again, this is completely different from the slicing that we talked about um, some time ago, right? So instead of the indices that should go inside the square brackets is the keys. Okay, so the keys. So this method one, we've already done that. However, we haven't done this dot get. And personally, I don't like this one. It's just too lengthy, but it accomplishes the same thing. So for example, I want to apply the dot get in here. So print me dot get um, first name. So if I apply that here, as you can see, it's just similar. So this is just similar to um, when you do this with me slice it with the first name. They are just exactly the same. So as you can see, it returned the true because what I'm asking here is a conditional statement if this one is just equal to this one. Do you follow? So it depends on you. It depends on you. For me, this is my go-to method when I want to get a value, um, the value of a dictionary. It's just shorter, way shorter. Okay, so that's something that's easy for us, and um, we have here the following methods, the following functions, right? For the first bullet, we have the items method returns the dictionary's key value pairs. So um, well, I don't usually use that because you can immediately print the thing, right? So um, it would just give you the same thing. The items would be the key value pairs. Why not just directly print the thing, right? Directly print the dictionary. So in that way, you would consume less time typing. And then the keys. So this keys and values. These are useful. So if you want to get the list of your keys in your dictionary, you can apply the dot keys. Okay, so here, um, how do we do that? Just apply the dot keys. So me dot keys, um, simple as that. It would give you the list of your dictionary keys. So you cannot apply that to like list. So if you create my list here, so me list is equal to me dot copy. So if you do this and create a my list or a me list, which is a list, by the way, not yet. It's still a dictionary, but now I'll be converting it. I can do it immediately right here. List me list is equal to list of me list. So if you try to apply that to a list, you would you would you would encounter this. So what I did here, I created a copy of me, which is a dictionary, using the dot copy function. You can apply this to whatever data structure, whether a data frame or whatever collection you have. And then I converted it to a list in this part so that I can show you that it cannot be used with list and even with tuples because you don't have any keys in there, right? So this method is specifically for dictionaries. It's unique for dictionaries. Do you follow? So that's what
Yep.
we have in here. Awesome. Thank you very much for the response. And you can do the same thing as with the values. I mean, these are just methods for um, where should we do that? Maybe here. By the way, you can immediately add like a cell here through Control MB. But sometimes it's way faster to just click on the plus code. So just add that values at the last part and the or immediately after your dictionary, and there you go. You'll get the items. And let me think. Hmm, let's see. Yeah, I think that's it for this part. So I think the next one is a practice. Well, this is just easy. I mean, I think you need a more difficult one than this that you will be getting in lab. So this is just applying the dot item to the dot values, which are very easy, and we have already shown it. We'll skip this part, and now this is something. This is something that I need to highlight: adding slash updating entries. Okay. Um, we can add new entries in a dictionary by simply assigning a value to a key. Python automatically creates the entry. So while dictionaries are unordered, it's completely mutable, right? You can easily change the values or even the keys associated in here. So in this case, we are adding a new entry in the phone book. Remember that we don't have Thor in there. We have Batman. We have I forget the other um superheroes there. So we will be adding Grace. Okay, let me see. Um, have we created it here? So we will be phone book. So let's add Grace in here. Um, so I forgot the other. I forgot the other superheroes earlier. Can you recall that, guys? Um, I have this very short memory. Spider-Man, Batman, right? Who is the other one?
Wonder Woman.
Okay, yeah. We have two women and two uh men in this list, in this dictionary, rather. So we have Wonder Woman here. And then we have Grace. Now, no. Let's add Grace. Uh, okay, Grace. Tell me, how would I add you here? How would I add you in the phone book?
Can you use like an append feature?
Unfortunately, the dot append is a method for lists. So, okay, let me show you again. So, any ideas?
Oh, that's it.
Okay, so can you tell me how I would add you here in the phone book? So,
Um, you do phone book
yep,
parentheses
okay.
and my superhero name, capital G.
Wonder Grace?
Yeah. No, not Wonder Grace. No, my name is Ganda Grace, okay? For
Got
Maganda, okay?
ah, that's awesome. I was about to tell you that the meaning of that is beautiful, and I almost
Okay.
forgot that you stayed in the Philippines for quite some time. So yeah, okay.
I don't know if I know this next part. And then you're gonna go
Hmm.
that and then colon my number.
Okay,
Oh,
your
not
number is
inside.
say
It wasn't
eight eight.
inside, was it?
Yeah, 888. Like it's like the number here for emergencies. So there's something wrong, Grace. Uh, there's something wrong with if we try to run this, we'll encounter an error with the semicolon.
Don't you have to put the colon outside the parentheses?
Sorry, can you say it again?
You put the you put the key in the parentheses and then outside of it colon and then the number, the value.
Um, I put the the keys. Um, no, can you say it again? I wasn't able to fully process it.
Aren't you supposed to just put the name inside the parentheses and then the colon outside?
Ah, okay. The colon outside, something like this.
Yeah. Was
Mm,
that it?
okay, so let's say it's There's something illegal here. Illegal target for annotation. What where do we use the parentheses typically?
The
Like this,
function.
yeah, like this format, it seems like we're applying a phone book function, right? Like for example, no, I don't want to jump into creating a function. It's like way back, way forward. But uh, what the structure that we have here is we're treating the phone book as a function, and the ganda grace inside is we are treating it as an argument of the phone book function. That's what's happening right here. So how do we change this so that the system would recognize, ah, you're trying to go inside the collection, and you're trying to alter the objects inside it. How would you present it in that way so that the system would recognize it that way?
I'm sorry, can you repeat that?
Sorry, Grace?
Can you repeat that?
Yeah, currently what the system is thinking is that this phone book is a function because it's the typical setup for applying a function, and the thing inside the parentheses, it's thinking that it is an argument of the function. However, we haven't defined any function such as phone book. So um, the structure is currently incorrect. And what we want the system to see is that we're accessing the inside of the dictionary. So currently we're not doing that. So how would you change this in a way that the system would understand that you are trying to access its objects? This is some similar thing. Whether you try to add a new one or you change an existing one, you have to access the inside of the dictionary. So that's what we want to the system to see. So why not change this to square bracket? Don't you think that the system would think that, okay, you're trying to access the elements inside phone book dictionary, right? So let's make the other parts first a comment. So let's try running this. Okay, good. We still have an error. What is the error telling us right now? It's telling us that this key that we're trying to look for inside the phone book is not yet existing, right? It's perfectly fine. Why? It's not yet existing because we're trying to create a new one. So when we try removing this and run it again, it will give us, well, I was not expecting that to be honest with you. I was expecting an error. Um, let's see. So it did nothing, basically. It did nothing. It did not throw us any error. Let me think. Ah, okay. I know the thing here. So what's actually being done in here is looking for Ganda Grace key, and then that is associated with the value of 888. It doesn't find that. Hmm. But it did not accomplish the thing that we want. What we want is to add U inside the list. And we can do that by putting this inside the square bracket. Now what we're telling the system is, in the phone book, okay, if Ganda Grace is not yet existing, you create one and assign a value of 888 in here. Do you follow? Grace and the group? So if we run this, you would see that, okay, there's an error, an hashable type slice. Wait, let me think. So should it be? Can I assign to literal field? Maybe you meant no. That's what the wait. What am I missing here? Phone book and the grace. This looks good. What am I missing? And hashable type slice. Hmm. Am I missing anything? Let's go back to the.
How about the underscore that you use? Is it
Ah,
usable?
yeah. Sorry. My bad. It should be this way. So the earlier format was actually correct, but I just have to change it to equal sign. So there we go. Now that I think about it, um, yeah, let me show this to you. I think we have covered it in with list, right? Let's create a list here. New list. Say 1, 2, 3. Let's print that list, and then say I want to change new list equal to 0, and I'll be assigning it a value of Jeff. And then I want to print it again. Just want you to show the similarity between the structure of the two. So there we go. So we're actually doing the same thing here. However, instead of specifying an index value, what we're doing here is just we're specifying the key. Okay. So since dictionaries are unordered, right? We cannot use the index values. It doesn't exist. So we use the keys because the keys identify the specific entries in your dictionary. Do you follow? So my bad, I forgot that it should be outside, and it follows the structure that we did with list. Again, uh, the most comfortable. I gotta be honest with you. The most comfortable data structure I am is with list. I always prefer list because there are tons of methods that I can use with it. But it's also nice that you know this other data structures because in the future you'll be most likely working with them. So here, even we can associate any like we can associate even a list with here. Like for example, uh, Grace has like two numbers, right? Maybe 333. Is it 333 on the other side or 444? Right? It's completely possible to do this. And let's print the new phone book. And there we go. Well, you'll see that Grace would have this two numbers. Do you follow? Is that even clear? Questions, guys? Questions? Even with tuples,
So
you can even
if you want to use the phone book to find my phone number, so it would just
Mhm.
be phone book bracket quote my name,
Phone
and
book.
then you could hit play on that,
Yeah,
and it'll
the keys on that would show if you do that. Yes, you're accessing the associated records with the key Grace, Ganda underscore Grace,
and so the only
right?
difference is when you add and equals this, it
It's
reads it
changing
as
it.
adding.
It's adding if it's not yet existing, but like now it's already existing, Ganda Grace is already existing as a key. But I can manipulate it, like I can add further. So it's a way to add new things if it's not yet existing or alter, change the one that you currently have, right? So it's a like a uh, it has two functionalities. Do you guys follow? So yeah, that serves two purposes: adding new entries and changing entries. Okay, so that's actually what we have in here. The same process. Well, the key takeaway here is this thing, and this is not new to us. Instead of accessing the object inside the collection via the index value, we are now accessing it via um, the keys of the dictionary. So that's just the difference between how do you do this here as with tuples and lists. And you don't have to memorize it. Again, they are comparable. Notice that I forgot how to do this, but I suddenly remembered, okay, that's how we do things with lists. So they're comparable. So I can definitely do that in here. Okay. So, yep, I think we can proceed. Removing entries. So here I'll be introducing to you a new function called del.
And one more question. It's
Yep.
case sensitive, right? So if you had searched it like without the underscore or like with a capital, then it won't return anything.
Yes, it's very specific. So it's case sensitive, and if you remove this, okay, let me ask you what happens if you remove this. Well, it would recognize that this is a completely different thing, right? So it would throw you an error. It doesn't exist yet. And if I, like for example, remove this, okay, let me ask you, what does the system see in here? How would it think? How would the system react if it sees something like this?
It
Okay,
won't find it.
it's not yet. Yeah, it's not yet a total error. It's lacking something. So let me fix it for you. If I say Ganda Grace is equal to say um notice once I assign this, create this, the yellow thing here disappeared. Um let me think. So we associate it to one. Okay, so let's run this. Now this thing without the quotation marks, this is now a variable in which the value stored in it is one. So basically, this is just similar to phone book sliced with one inside the square brackets. Does it make sense? So if we run this, okay, it would look for a key equivalent to one, but you don't have that. So let's assign something that is existing, say Spider-Man. It would no. Should be Ganda Grace also. I'm not making things complicated here, guys. I'm just showing you what's going on under the hood. How the system sees what we're typing here. So if we put here um, this thing, what do you think? What do you think is happening? This is again just a name. It's just a variable. It's just a name that we associate to things. So this is just similar to saying phone book and Grace. Do you follow? Just similar to that. So as you can see, it returned true. Do you follow? Does it make sense? I don't want to confuse you guys. I don't want to confuse you. There's just difference if you remove the quotation marks. The system would think that you're referring to a variable. If it's not yet existing, then it would throw you an error because it's not yet existing in the memory of your system. But if it exists, like here, it would capture the value associated to that, and it would use this or that value in this next statement. Do you follow, guys? Please let me know. Grace, was this even clear?
We may have to practice that. Are you trying to the one in quotes? Is that supposed to be because you said dictionaries are keys and values, right? So is the
Yes.
one in quotes supposed to be the value?
No, those are supposed to be the keys.
And so when
So-
you ran it, you're
Mhm.
saying Gunda Grayson phone book is equal to Gunda Grayson phone book.
Yeah. So what I want to stress or emphasize on this thing is the difference when you remove the quotation mark versus you have the quotation mark. So when you don't have the quotation mark in there, the system would look for an associated value because it treats this as a variable. However, if you have a quotation mark right there, it would immediately think, okay, you're accessing the dictionary. If that thing inside the quotation mark is not yet existing, it would create a new key and any associated value to it. If it's existing, it would change the associated value depending on what you assign to it. Like for example here, if we change this, we can actually change the value of the key Ganda underscore Grace to say um, uh, I'm not sure what other value, say 777. But when you print phone book now, you would see that um, instead of seeing this, you would see a different value associated to you. Now a 777. Oh, currently it's a list, so I can remove this. Okay. Yeah, please let me know. So I can dive on this deeper so that I could clarify things. I just want to know if it's already clear so that we can move on to the other topic. But I'm good to stay in here and um look for other better explanation on the aspects that you find confusing. Hasiba, Jeff, Anissa, Grace, is everything clear?
Yep.
Okay. About the others, any comments, any violent reactions?
Honestly, I would need more practice.
Yeah, you will have more
Yeah.
practice. But the concept, yeah, with I understand that with programming, it's really important that you have that hands-on experience because you cannot master it just by looking at it. But what we do during lectures is to explain to you how things are why things are working and how they are working. The muscle memory would be developed during the labs. I see Anissa typing. Anissa, you can just use your microphone. It's if it's possible. Okay, there's too much noise. Okay. Uh, I'm just trying to catch up on what we're going over, so I don't have. Yeah. Okay. Hmm. Understood. Understood. We just talked about the dictionary, and hmm, let me think. Yeah, I think it's it's good that we move to the next topic. The deleting entries. How do you delete an entry? Again, this part right here, guys. Uh, what this is doing is it's accessing your dictionary. Okay. What is Wonder Woman here? Wonder Woman is a key. When you apply the del function before this, you are saying that delete Wonder Woman, and it will not only delete the key, even the values associated to it, all values would be deleted as well. Okay, so that's what we're doing here. So let's have again phone book, right? So the phone book has Spider-Man, 555, Batman, and so on. So suppose that I don't want Batman in there, right? Okay, um so Batman, we don't want him here in the list because it's not answering the phone book. So Batman. Oh, okay. So I want you to identify what's the problem here. What is the system thinking when it encounters the statement? It's reading it from left to right. Del has no issues, right? Once the system encounters the del, it's thinking that you want to delete something. And here, what we're trying to do is to access Batman. But what do you think is the problem with the structure? Everyone can answer.
Should it be inside quotation? Batman?
Why? What's the difference if it's inside the quotation mark or not? How does the system think? Or was it what is it expecting if Batman is not inside the quotation mark? It's thinking that Batman is a variable, right? It's a variable. So that's why it's yellow in here. So it's not automatically an error. It's just telling you that once it is yellow, um, it's a perfectly valid Python statement, Python code. However, you're just lacking one aspect. And what is that aspect? I haven't defined Batman yet. If I want to treat it as a variable, then I should define it. Currently, in the system's memory, no variable is named Batman. So it would give us an error. So the system is telling us name Batman is not yet defined. It's not even existing yet, right? So now if we enclose it with a quotation mark, what it does is, what the system is thinking is, okay, from the phone book, you are accessing Batman. Batman is a key, and you're applying the del function to it. So once we do that, you apply the del function. This is once, okay? We should expect that now there is no Batman in our dictionary. Now, what happens if I run it again? We would be expecting an error. Why? Batman doesn't exist. Okay, so you run it just one time. So the moment you run it again, it would look for the Batman again here, and it would tell you, okay, it doesn't exist. The key doesn't exist. Okay, do you follow?
Yeah, so you got to run the other ones, the previous ones again.
Yes.
Then it'll work. Yeah.
Yeah, you
It's
have
just
to run
basically
everything
the same
again.
thing as the issues we run into when we do methods. Right?
Yes. Yes. For example, applying the dot pop over and over again would remove all of the um, elements of your list, the last elements of your list. if you do that over and over again, it would just obliterate all of your elements until it becomes empty, an empty list. Okay. So yep. So that's the del function. Um, Actually, the del function is very useful. Uh, you would encounter that and use that in other data structures as well. Would it work with the list? What do you think? Or a let's explore. I don't want to jump from one topic to the other, but it's a good question, right? So if I have a my tuple in here, say that tuple is consisting of 1, 2, 3. Right, my tuple might be thinking, why is Jeff sometimes uses print, sometimes not. Um, I also don't know. So it would still work if whether you use the print function or not. Okay. So what if we apply the delete function? What do we need to do with the my tuple? We have to access a specific element, right? To tell the system what do I need to delete. So del my tuple. How do we access? Say 2. I want to delete 2. Can anyone tell me? How can I access element number 2? Anyone? How do we access element number 2? We can slice it, right? Still object slicing, the good old square brackets. And how do we specifically locate number 2? Can we use 1? What do you think? Will this work? So we're telling the system, okay, delete whatever is inside my tuple that is equivalent to 1. Are we referring to this value? Yes or no? Are we referring to the actual number 1 or something else? Any ideas, guys? So remember, tuples are ordered collection. So we can actually, well, we are using the index labels. So the 1 here is actually referring to the value with an index value of 1, not necessarily the value 1. Do you follow? Okay, it doesn't work with the del function. Maybe a list would do. Let's convert it into a list. Okay. List. Let's try to debug this. Convert the my tuple, creating a my list by applying the list function to the my tuple that we just created. And then let me see the error again. Tuple object doesn't support item deletion. Okay, this is a great question. Why? Why does it support item deletion? I almost skipped that part. What property of tuples makes it not supported by item deletion? Guys, I keep that question to you. while I debug this. Of course, there's a way to. There's a way to.
Oh, because it's immutable, right?
Perfect. Okay, perfect. That's the answer there. So we said last meeting that whenever a collection is mutable, you can change, delete, or alter the values in it after its creation. However, for immutable sets, you cannot do that. So the reason why the del function is not supported with tuples is because of that. Perfect, Jeff. Thank you very much. So my list is I want to delete number 2, which is associated with 1. With the value 2. Okay. So I want to do it this way, and I want to print my list after that. This would do. Okay. And we know that lists are mutable collection, mutable data structure. So it allows us to manipulate this way. Do you follow? So this is the prime example. This is an important error, right? So this is an error that tells us that tuples are hashtag immutable. Oh, no. Okay. So I want to put it like that. If you want to like immediately put everything into a comment, you can do control slash. Okay. So control slash would put this hash mark in the front of your code. So was it clear why we encountered this error, guys? Remember that. Okay. Questions, clarifications about this? Okay. And yep, hearing none. I think everything's clear. Let's go back here. And length of the dictionary is just very simple. Just apply the len function, and it would um, give you the number of entries that you have. So basically, this counts the number of keys. Okay, the number of keys in your dictionary. This is another practice that I want you to do with John in the lab. John, can you take a screenshot? And data structure conversions. So we have done this a couple of times during this discussion, and I want to focus more on the reasoning behind. And I think I've highlighted it early in today's lecture. The reason why we switch from one data structure to the other is because of the methods that we can use with one data structure as compared to the other. Also, as what you have seen here, it may need to be converted to another data type because the current type is immutable. So if that's an immutable collection, then you cannot delete, you cannot alter the values inside. So um, well, it's a good thing and also a bad thing because if you want to manipulate the values, then you have to convert it into a mutable collection. But if you want to safeguard it, if you want to keep it from being altered, then stay on an immutable collection. Does it make sense? The reasoning behind? And the process, guys, is just very simple. Um, say converting to a list. So I've highlighted here list because there are so many advantages of using list. Tons of methods, mutability, right? And the way the way that elements or objects are presented in the list is just very intuitive, right? So that's why I highlighted it here as first, how you would convert this tuples and this dictionaries into a list. However, um, I have here some distinctions, especially for the case of the dictionaries, because you have the keys and the values in that data collection. So if you want only the keys to be converted, so you have to apply the list function immediately to that dictionary. However, if you want to keep both, okay, both the keys and the values in the resulting list, you have to apply the list function with the dot items. And the resulting is what you call a list of what? So this resulting list is what we call a list of what is the structure of this values, guys? It's a tuple inside the list. So the key value pairs would be a tuple, but it's inside the list. Do you follow that? Guys, do you follow the result when you get both the keys and value, the key value pair? The resulting list would be um, consisting of a tuple inside the list. So this would be considered as one element of the list, which is a tuple, another element of the list, which is also a tuple. So let's see that. Okay, maybe a much simpler example would do. So let's create here a new dictionary and say we associate values, say for A to just 1, and then B to 2. Let's keep things simple, and then C to 3. Okay, so let's convert. So convert dictionary into a list. So key only. So with that, this is the simplest, um, simpler version, like mm, new list would be list. So this one would give us only the keys. So that would only contain ABC. Right? Now, uh, include the key value pair. So how do we do that? So remember, we have the dot items earlier, right? So if you have a new dictionary and you apply the dot item method to that, it would give you the key value pair, right? So we will use that idea. New list 2 would be in the list function applied to this. So basically, you're creating a list out of this um, collection of tuples. Okay. So if you apply that and you print a new list, then you would see that it is a list, but it has tuples in it. Okay. And how do you access those things? Well, it's just slicing. So this has an index value of 0. If you want to get that, you just do it like this. It would give you um what is giving me only it should be new list too. So this new list is actually referring to the one at the top. So this should be A0. And then when we apply type into this, you would see that this is a tuple. Do you follow? So it's a tuple, set of tuples inside the list. And um, what if you don't want it to be a tuple? You want it to be something else, then you would have to convert it. But typically, if you convert one like from a dictionary into a list, you will better that you have this kind of format because you can easily access those associated values, the key and the value pairs. You don't want them to be separated with each other. Okay, and now you can apply the methods that you know with list uh, in this that you cannot do with dictionaries because dictionaries are unordered. So, yep. So that's it. That's how you get the key value pairs in a dictionary and convert it into a list. With tuples, it's straightforward. I mean, tuples, as you can see, the major distinction is that you have parentheses and in terms of character, they're both ordered, like list and tuples are both ordered. However, the difference is on the mutability aspect. Um, Lists are mutable and tuples are not. Okay? Okay, guys. Questions? Questions? Are you good? Are you still? I forgot again to give you a break, so you may be.
Yeah, I
Um,
was just gonna mention that part.
yeah, I think you're already tired. Listening to me bubbling about these things for the past almost 2 hours. So before you transition to lab, John, please give them a break so that they can refresh. I think it's important that yeah they have a break before they practice. So let's see. I think that's all for today. Um, yeah, tuple again, straightforward. Um, hmm, let me think about this. I rarely use. I rarely convert to a tuple because it's quite difficult to navigate through tuples. Mostly list. But just apply the tuple function. To be able to convert it. List to tuple, tuple to list, very straightforward. With the dictionary, I think that's quite different from the others. Okay, let's see this. Yeah, dictionary is also pretty straightforward. Assuming that in your list, if you're trying to convert a list into a dictionary, it's like in a way that you have a key value pair, like on a tuple format. If you don't have that, then you won't be able to create a dictionary out of the list. Okay, it's not possible. So make sure that you have that either nested list or nested or a tuple or a list with a tuple. So I think that's it for today. You have this practices, John. Please give them this practices. So starting from tomorrow, things would be quite more complicated. So for tomorrow, we will be discussing conditional statements. The conditional statements would, uh, well, it is more complex in a sense that you don't just need how to write codes. You would be combining logic with it. Okay. Let me show you the topics that we have for tomorrow. Slideshow from beginning. Okay. Do you still see my screen, guys? Okay. Cheers. So, yeah, conditional statements. This is more of yeah, knowing how to write the codes, knowing how to set up logics in Python. We will also see how to create our own functions here because it's important that we don't only rely with the built-in functions in Python. It's better that we know how to create our own. The good thing with it is you can customize it depending on your need. Um, in some technical interviews, they would be asking you to create your own function that would do a certain task. So you need to be well versed with the creation of a function. The logic aspect is quite difficult to teach because it's something that it's typically innate with people. But what we'll be doing in class is we'll do it step by step. Okay, so we'll make sure that the logical steps are set in place from the initial um, initialization of the logic of the function and then to the desired output. Okay, so that's what we'll do in here. But to be completely honest with you, you can master this through practice alone. It's impossible for you to become become a master of it just by looking at it. Conditional statements, uh, you have to practice and practice and practice. Invest more time. So that's it for today's session. And tomorrow I'll meet you once again for another lecture. So thank you very much, guys. I'm happy that all of you are here. So see you again tomorrow. I hope you learned something. Today it's quiet, suspiciously quiet. So, but just let me know if something's unclear. I would be happy to go back to it. Okay. So just to give you maybe like a status of where we are right now, we are halfway through Python. Halfway. After that, it could be Power BI or statistics, probably statistics. So it would be maths. Okay. It would be maths and then programming as well. So bye bye.
Thank
Take
you.
care.
Thank
Thank
you.
you.
Thank you, Jeff.
Okay, before we proceed to the lab session, before we have some practices lab, let's have a quick break.
Hey, John, when we get back, can you go over real quickly the uploading into Google Colab? I forgot
Okay.
how to do that. And the
Okay, sure.
the one due this weekend is like that, right?
Okay, sure.
Okay. 10 minutes?
Okay, let's go
Okay.
back after 10 minutes. Hello, everyone. Are you there? I think we can proceed to the lab session. So Anissa is here. How about Hasiba and Grace? Hello.
I'm here.
Thank you. Is my voice clear?
What?
Is my voice? Can you hear me clearly?
Yes.
Okay. Thank you for that. So let me show you the way. So just like Grace is asking a while ago, let me show you how to upload again an IP by NB file on the column. Okay, so the lab 24, it is an assignment which is in which the file is an IP by NB file. So the first step is to download this file on your device. And then after that, you are free to go to the Colab. So on your browser, you can just search Google Colab and click the first link that you will see there, or the second link. So after you click that link, this is the thing that you will see at your screen, or this should be the thing that you should see at your screen. So after that, you need to click upload and browse and find the file that you just downloaded. Tab for Python, and then click open, and it will be automatically loaded on the Google Colab. Okay. And then if you want to save that as PDF, you can print it. Print, and then under the destination, make sure that it should be save as PDF. Is the thing that is selected, and then save. And then you will find again some place to save your file for us to save it as PDF.
John, since you're in this file, I have some. I couldn't do the number 6.
Okay, 6.
Yeah,
Okay,
this one.
6. How about the others? Have you already tried it, Grace and Anissa? Yes, Grace.
Oh no, sorry, that was the wrong one. No, I tried it today at work and I couldn't remember, but I was in a view of Google Colab where that box wasn't coming up. So I was hitting plus code and then that 3 bars on the left. And so I just gave up. I had to go back to work, so I wasn't able to look at it today.
Okay. So that's understandable. This one, this one number 6, Hasiba. First, you
Yes.
need to access this part, and then use insert since you need to specifically enter 5 at the middle of 4 and 6. Okay, so let me ask you a question. How can we access this element, this list inside another list?
Um, by insert.
No. Just access. How can we access this?
So
This part.
maybe like my nested list 2 is equal to
My nested list
yeah
is equal to.
is equal to uh, open square bracket 4 comma 6.
4
Oh,
comma
maybe
6.
parentheses. Yeah, I
Okay,
believe.
so what's the idea of accessing this? We are using slicing, right?
Mm-hmm.
So this is a list inside a list. And that if that is a list inside a list, So maybe we can consider that as one object. So how many are the objects inside my nested list? 1,
3.
2, and 3. So there are 3 objects. And how can we access this part?
If we use slicing, a column, then 1. I'm not sure.
Okay,
Yeah.
let's use this instead. How can we access the second element from this list?
Pop.
How can we access this second element on this list? What's the syntax for accessing or slicing lists? The format is
Insert.
no, insert is
Ah.
used if you want to add something, right, in the list.
Yeah.
But in this case, you just want to access this. Remember that the format for accessing items is this, right? Variable name followed by a square bracket and then start stop step for multiple items. But if you are accessing only a single item, it should be like this, right?
Okay.
Do you remember it? This one? Variable name followed by what's the index? Let's create another example. For example, we have name, which is John. How can you access the second element of the string?
You say name 1,
Name, and then this,
open bracket, and 1. Yeah.
like this, right?
Yeah.
For you to access this second element.
Mm-hmm.
That is for the strings. But remember, the way we access elements for the strings is the same way we access elements for lists and tuples. Okay, going back to this. Okay, so the pattern is you specify the name, you call the name of the variable followed by its index and close in a square bracket, right?
Mm-hmm.
Okay, applying the same idea, how can you access the second element of this? You have favorite numbers. Okay.
Yeah. Favorite numbers, open bracket, 1.
Okay. So that's the idea. If you want to access something, what you need to do is to treat it just like how you treat strings. Okay. So this part, we are accessing the second element by treating this as the element that is a zero that has 0 index. This has 1, 2, 3, 4. So if you want to access the second element, you need to type it this way. Okay, so this is a list, right? And you can determine the number of elements inside a list. Okay, the distinct number of elements in the list based on the comma. So as you can see here, the elements of this list is separated by comma. Okay, extending that idea. Okay, this is a nested list now, right? Focusing on the yellow brackets outside.
Mm-hmm.
You are interested on the list that contains this. So the goal is this. Access the list that contains 6 and 4. 4 and 6. And then after that, insert 5 in that list. So before the insert, you need to access first. You need to successfully access first this part.
Okay.
Okay, can you tell me how can we access this? Second part.
Minus the list.
Minus that
Open
list.
bracket 1.
Okay, open bracket of 1. And let's see what would be the result. Okay. Now, you know that this part, okay, this part will give you this 4 and 6. Now, how can you insert 5 between 4 and 6?
So
Okay.
after bracket dot insert.
Okay, that insert, let's try that. Insert. And then what's the syntax for insert?
Minus the list. No.
Okay. Insert
No, I don't know
has
this
2
part.
parts. Insert has 2 parts. First is the index in which you want to enter the information, and the next part is the information. Okay. Let's say this part. This is a list, right? And let's say you want to insert 10 at the second element. So what's the index of the second element?
1.
Okay, 1. And what is the item that you want to insert? 10. So from on the favorite numbers, you want to insert 1 on this index of 1, this element 10. Right? So variable name that insert. So this is a list. Remember that this is a list. And you are applying inserts on that list. So if you run again the favorite list, favorite number lists, let's see what would happen. As you can see here, you successfully inserted 10 on the index 1. Right? So the pattern is list followed by inserts and then index and followed by the thing that you want to be inserted. Okay, following that same logic, you know that this part, you know that this is a list, right? This is a list, which is equal to this 4 and 6. Okay, you can think of it that favorite numbers is a list, right? And you can directly apply inserts on this list. Okay, can we apply insert on this, Hasiba? Can we apply insert on this?
I don't know.
What is this? What is the value of this?
This is the index that the list that we wanted to add another number.
Okay, this is a list, right? If this is a list, can we apply insert?
Yeah.
Oh, okay, let's try. Insert. What is the thing that you want to insert on this? Remember that this my nested list 1 is a
One,
sublist, which is
1
this.
comma 5.
Okay, let's try that. 1 comma 5. So I ran it. So to see if that actually applied on our list, let's try to call again our list. Okay,
Oh,
it
yeah.
worked.
Yeah.
So I think you know what are the things that you need to use. However, you are not sure of how you will type it. So I suggest I suggest you create like a lecture or a Word file that contains the methods, like a note wherein when to use inserts, when to use remove, and when to
Okay.
use
Yeah.
like this. What is the other one? Like for example, append. How can you use it? And like a single example, so that if you encountered almost the same question, you have an example beside your notes that you will easily take a look into it. And the idea is just extending. Like this is a list, right? This my nested list 1. We know that this is a list initially equal to this 4 and 6. And if that is a list, since this is a list, we can apply insert, since insert is a method for lists, right? And to use
Mhm.
inserts, the things inside that are 2 parameters, index followed by the thing that you want to be inserted.
Okay. Got it. Thank you.
Okay. Okay, sure. So we are always using the slicing. So always remember that the pattern of the slicing is variable name followed by the index enclosed in single item, in square bracket if you are dealing with single item access. You are accessing single items only. And the concept of the start, stop, and step if you are trying to access multiple files, multiple items on our iterable object or lists, tuple, and a string. So this idea is the same for all of them. Okay, so I think this 6 is the most challenging part. So I think you will be able to perform almost everything on this. 6 would be the challenging part if you will answer this lab 4 in Python. Okay, I think it's we still have 33 minutes left. So let's try to use it to practice our uh, latest topic about the dictionaries. So I prepared some practices in the dictionaries, but let's take a look first on the contents. Let me see if this is the thing. Okay, this, and let's go back of the practices that are in here. Okay, I think I will save it on, or oh, no. Let's just use this. I will send in I will send it on the Discord. This file. Because I think using that 15 item practice, we can understand how this works. So I sent a file on the Discord. This file contains 15 item questions, and it is all about dictionaries. This is something that is conceptual, wherein all of the questions are connected to each other. Okay, 15 items, but I think we can practice everything that we have discussed today. Okay, first, number 1, create an empty dictionary called store prices. So let's copy and paste it on the column. At the first parts, I will be the one who will perform this. Okay. And then I'll maybe some I will call someone later to perform the other items. Okay. So for the number 1, create an empty dictionary called store prices. Can someone tell me how to create a dictionary? We have 2 ways, right, of creating a dictionary. You can tell me even only one.
Curly brackets? Variable name and curly brackets?
Curly bracket? Yes, that is the thing that we can use to create a dictionary. So for the number 1, it says create an empty dictionary called store prices. So I will assign it in the variable name store prices, and let's just have a square bracket, curly brackets rather. So this alone is already a dictionary. Okay, so let's try to determine its type just to be sure. What's the type of store prices? It is either a set or a dictionary. Okay, this is a dictionary, an empty dictionary. Okay, a dictionary that doesn't have any content. So we are done on number 1. Now, add an entry to the store prices dictionary with the key apple, and the value is 0.5. So for the number 2, what we want is on our dictionary, okay, we need to add something on this. Okay, anyone who still remembers how to add an element on a dictionary? How can we add elements on a dictionary? Okay, let's go back to the,
You can use brackets, straight brackets.
yes, we will use square brackets to add.
Or square brackets.
Okay, let's go back to this. Okay, can you tell me, Grace, your idea?
Store underscore prices, open
Store.
bracket,
Prices, open brackets, and then
quote apple.
quote apple.
Yeah. And then outside of bracket
Okay,
equals
equals
space 0.5.
0.5. Okay, so the idea of Grace is calling the name of the variable, which is this, the name of the dictionary, and then inside square brackets, the key apple was typed, and then outside the square brackets, it was equated into 0.5. So let's see if this will work. So I hit run, and it says okay. Check. And to see if this one is now updated, let's run, or let's call store prices. Okay, so our store prices dictionary, in which it is initially empty, now it contains this. Apple as the key, 0.5 as the value. So this syntax is correct. Okay? So remember this. Okay. On the numbers 3, the same approach. Okay, Hasiba, can you tell how can we do this part? Add
Sure.
another entry to store to the store prices dictionary with the key banana and the value is 0.3.
So you should write store underscore prices.
Okay? Store
Uh, op-
prices.
Open bracket.
Okay?
Colon? No. Quotation?
Quotation.
Yeah. Banana.
Banana and then
Then equal to 0.3.
0.3. Okay, let's run this and then it says check. So meaning there's no error. And to see if the store prices was updated, let's run again the store prices. Now, it should have apple, which is equal to 0.5, and banana, which is equal to 0.3, right? So, okay. We now have apple, which is 0.5, and banana corresponds to 0.3. So, that's how we add things inside our dictionary. You can continue adding items on the dictionary. Let's say I also want to add cherry. Let's say it is equal to 0.1, 0.1. I will run it and says there's no problem. It is check. And to see if the store prices were updated, okay, we now have apple, banana, and cherry. Is this clear? Is this part clear? Do you have any questions on how to add entries or new entries on our dictionary? Or everything is clear up to this point? So,
Good with me.
okay, clear. Thank you for that, Grace. How about Anissa? Okay, for Hasiba, that is clear. Okay, so let's continue. 4. Retrieve the price of apple from the store dictionary. So, how can we retrieve it? How can we access or how can we display the price of apple? We know that our dictionary is this. Okay? Apple for 0.5, banana 0.3, and so on. What if we have a lot of items inside our dictionary and we are searching for what's the value of apple? How can we do that? You can take a look on your on the presentation and see the pattern. How can we do it?
You just do like line 5 without the equal sign. Because it
Line
can
5,
search.
this one.
Yeah.
Okay, let's try that. Store prices and then apple. Let's see. Yep, that syntax is correct. Like, okay, let me give you a tip about dictionaries. Type or store prices. Let me give you a tip. Like, this is somehow the way I understood dictionaries. So naturally or truthfully, dictionaries is a type of data structure that is unordered. Okay, dictionaries it is unordered. What do we mean by unordered? It means that indexing does not apply. It is not applicable. So the arrangement of this, so one thing about the unordered, that's why you cannot assign 0 for this, 1 for this, 2 for this, is that its arrangement doesn't matter. Okay? If we put banana 0.3 and apple at the middle, so we switch their places, it is still the store prices dictionary. So its arrangement doesn't matter. That's why you cannot assign indices that are fixed for this. Unlike the lists, right? Unlike the lists, wait. Unlike the lists wherein you have this structure, you are sure that this part is the first element, say this part is the second element. They have fixed referencing. So the first element is always the element that has the 0 index, and the last element is the element that has the -1 index. That's always the case for ordered type of data structures, but that's not the case for unordered. Indexing does not apply. So on the ordered data structure, how do we access elements? We access them using the syntax. Variable name, okay, let me just copy that. Let me just copy the things that we have talked about here. To access elements of ordered, it is like this, right? If you want to access elements of an ordered data type, the syntax is variable name followed by some index and this if you want slicing. But in the dictionaries, the pattern almost looks the same, like this. Variable name followed by the index. But instead of using the index, you are using the key. So just like what Grace did here at this part. Okay. We have this star prices. Let me run that. Let me run first the store prices. Okay. We have this store prices in which apple corresponds to 0.5, banana corresponds to this, and to this. But if you want to display this pair, like what's the price for apple? So 0.5 is the value. So since this is unordered, indexing does not apply. But you can actually use the key and treat it like it is not right to think of it as that is the index of 0.5, but that is the key. So as you can see, the syntax is the same. The pattern, rather. Variable name followed by key. That's for the dictionary. But for the ordered types like list, variable name, and then index. So that is one of the ways you can remember how to access elements of a dictionary. Okay, there is another way. So let me just put here the code of Grace. There is another way, and that is by using, okay, can you still remember it? Anyone? How can you access, how can you perform the same thing without using this syntax? By using the method designed for dictionary. If you want to get the price of apple, you can use the .get apple, and it will give you the same syntax or same result. This or this, they are both accessing whatever the value of apple. Okay, is that clear, everyone? store prices. So it is on this part. This is eating. Okay. As you can see here, method 1 is by using square brackets, phone book, Spider-Man. So this is our dictionary. Where is it? Our dictionary is this: Batman, multiple fives; Spider-Man, two twos; Wonder Woman, multiple fours. So here we can see that we can access them two ways. One is by using the square brackets, so phone book, Spider-Man, and the other one is by using the dot get, and then inside the parentheses, Spider-Man. So that is the same thing that we applied here. Okay. Okay, let's proceed. What if you want to update the price of the apple? How can we do that? Initially, apple is 0.5, right? So what if there is an inflation? You want to update 0.5. So how can we somehow update its value? Anyone? Okay, let us show the answer. First, access Apple. Okay, access Apple. So that's the first step. But instead of running it, okay, equate it to the new item. In that way, you can update the elements, or the you can update the price of the apple. So let's show this. Okay, from 0.5 a while ago, now it is 0.6. Why is that? Maybe I will explain the reason behind this, and then we will continue our discussion or practices tomorrow. So because I want to highlight something here. Okay. So in dictionaries, it has this what do you call this? So let's consider this dictionary. Let's consider this dictionary. Okay. So we have a phone book which has, I am trying something a while ago. So I assigned A to 111, B to 222, and C to 333. And if you want to add something on your phone book, you are doing this, right? Initially, you can do a phone book or a dictionary that contains the same key. So let's say A is, is equal to 5, like this. Colon, rather. So A is equal to 555. So as you can see here, so let me remove this first. Python allowed us to create a phone book or dictionary in which somehow two of its components contains the same key. And in dictionaries, we say that same keys are not allowed. Somehow Python will allow you to run that. However, Python will allow you to create that. However, the thing is, only one of them will be retained. Okay. I will call phone book, and as you can see, A is 555. This one is gone. So this was recorded. This is, we still have two, B and C, which is equal to, which is this. However, do you ever wonder why this part is not at the end?
I was just asking that, like,
Okay.
if it was rewriting or overriding the first A, and order doesn't matter, why didn't they put the A555 at the end?
Yes, like why it is on the front, right? So this is the reason. Since Python is reading our codes from left to right, so this is the pattern, or this is the process. So Python is reading our codes from left to right. Now it reached this part, which is the curly braces. So Python will know that it is either a set or a dictionary. But initially, it will think that this is a dictionary. Okay, so Python will determine A is a key, which is equal to 111. So Python will remember that A is 1. So every time you will call A, it is 111. Okay, it will proceed. B is 222. C is 333. And then when you reach this part, okay, another A. I know that A is 111, but the user entered another A, which is 555. So what Python is doing is, initially A, it know that it is 111, but since there is another A, which is 555, 111 will be overwritten. Okay? So what happened is this. The process look like this. So on the memory of Python, so A is 111, B is 222, C is 333. But Python encountered again A, which is 555. So this one will be updated 555. That's why it is on the front. Does that make sense? Like the key retained. However, this
Yeah.
value 111 was updated to 555. That's why it is on the front. Just like this. And that is the same thing if you want to update your entry. Okay, first, how can we add another element to our phone book? Okay, we know it a while ago. We can add element on the phone book in which we are specifying the key, which is, let's say, D, and let's say it is equal to 444. Okay, so Python knows that you are entering another entry, which is D, and it is equal to 444. So when we run this, it is now here. D is 444. I guess let me remove this part so that our explanation will be clear. I just removed the duplicate key, and we know that the phone book is this. Okay, but here we applied or we added another entry. So in the next line, when we call it, you can see that. However, you are trying to add something again. Let's say you want to add phone book, which is equal to this. Let's say the lucky number 777. So the syntax is you are adding something, right? However, on your phone book, A is already there. So intuitively, if this will work, our dictionary should look like this. And we have A, which is 777. Right? If this line will work, we should see this part. However, based on what we talked about a while ago, at first Python will remember that this is 111. However, when it reaches this part, it is A, and you are somehow updating it to 777. That's why on the result, what we should see is this. Let me copy and paste here. And the result, we should see this. Okay. So let's try to run that. So if you understand how to add elements on your phone book, the updating of the entries will be easier because it is almost the same. It is the same. The only difference is when you are adding entries, the key is not yet here. Okay. That is okay. For adding is the key is not yet at the dictionary. But in the case of updating entries, the syntax is the same. Okay? Same syntax. The only difference is the key is already at the dictionary. Does that make sense?
I'm still confused. If we have another A with the number like maybe 555
Okay, let's add 555.
with A.
Phone book A is 555. A here is the phone book. In the phone book, A is currently 777. But now we are adding A as 555. So I will run this. So it is checked, meaning our phone book was updated. And to see it, our updated phone book, I will run this. You can see A was overwritten as 555. Since A is already a key that is in our dictionary, whenever it see a new value, the old value will be overwritten.
So it's just replacing the value?
Yes, exactly. It replaces the value. That's why the old value is gone. And the replacement,
Now today, John, in lecture, Sir Jeff, he was saying like, let's create a dictionary, and then he was using the colon and the equal sign interchangeably. Like you can use the equal sign for dictionary entries.
uh, that part is another way of creating a dictionary. Okay, let's say phone book 2. Phone book 2. If you want to use equal sign inside this entries, you need to use this function, the ICT. And then whatever you put inside, let's say A is equal to 111, B is equal to 222, 3 IC is equal to 333. So let's run this and call phone book 2, or better if I will separate this another cell. Okay, let's print this phone book 2. Okay, so this phone book 2 is recognized as a dictionary. And the way we enter things inside it is we are using equal sign. And the good thing by using the ICT is for the string part, you don't need to use quotation. However, for me, this one is more intuitive. This because somehow this one is straightforward. I don't need to use the function DICT. Because what the ICT means is whatever is inside this are being converted into a dictionary. So that's the logic behind that. Unlike this part or this version wherein you are directly doing or creating a dictionary using the square bracket, curly brackets rather. So putting them side by side, they are almost the same, but the difference is on this version you are using colon, and this version you are using equal sign. And on the key part, even if that is a string on this version, you don't actually need to close it by a quotation. However, this part is limited. There is a limitation on using this. When is that? If your key is an integer or a number, it will not allow you to assign it as a key. That's why this version is more useful compared to the other. And
Why
this
was it you cannot use numbers in version 2?
on version 2,
To
the keys are not allowed to be integers like this. If we run this, it will give us an error. Okay.
Why doesn't
Ex-
it allow it? But it will.
expression.
You can still create one.
Yes. Somehow this part does not allow us to assign integers as the keys. But this, so we will not encounter any problem for the phone book. It will allow us to do that. That's why this version is much more useful because it will allow you to assign that as the key. Unlike the other one, it will not. It somehow there is a mechanism on this function that doesn't allow the key as an integer. That's the case. So if you want to use integers, my suggestion is to give it a special character that somehow will not will present it as a string. So even if I enclose it with this, somehow it doesn't allow me to set this as a key. So it hates having a key that is an integer or a number, even if we explicitly convert it into a string. So commonly my strategy is to give it an underscore at the beginning for it to run. And this one works because this one is not treated now as a number. So my suggestion is familiarize yourself on using this version instead of the other version. I'm not sure why this doesn't allow us to assign keys, integers as keys. But in that reason, I am sticking at this syntax to create dictionaries. But it's good to that you have background that you saw that we can create dictionaries this way. But expect that this will be the thing that you would commonly see. You would see this second version commonly when we are typecasting or we are
Yeah, understand.
converting data types on a dictionary, data structure rather. And if you are just creating a dictionary, you would see this more frequently compared to the other. This one is for converting. That is the time that you would see it. And I guess I overtime by 4 minutes. But I think I hope we can continue using this tomorrow. We are on the number 5. But I hope it is clear how we are updating the what happens when we have entries that have the same key, what is happening under the hood, and why that is the basis to update entries. But if that part is not yet clear, we can still go back to that tomorrow. Okay? So any questions or concerns?
At least that 136 made perfect sense. So thank you, Joe.
Thank you, Grace.
Thank you, John.
Thank you, Hasiba. See you tomorrow for another discussion with our instructor. Thank you, everyone.